Hello guys, welcome back to another episode of eBPF programming. In this part 4, we'll be exploring how we can leverage eBPF and LSM to develop a WAF kind of module as a pluggable module. If you ask me, is it going to be a WAF? I would say it is, but it's not the way that the normal WAF works. Because we can hook only system level or user level application probes using eBPF. Is not like we have a full-fledged WAF that works before the request coming to the application or something like that. It doesn't work like that, but it is very effective when if you have control over, if you know how your application works. And suppose imagine there are some scenario that you may not have any possibility of doing WAF into your application, but still you have to restrict your web application doing some activity. So in those kind of scenario, you can utilize eBPF and LSM to create these kind of defensive blocks. So if I explain more, it may be complicated for you to understand. I will show you how it works. And regarding the other parts, I'm utilizing the same hook that I used last time for preventing pseudo privilege escalation. So the hook point is same. So how the hook point works and when it is getting called, when we can put our hook, all these details I explained on my last video. If you are interested, you can go and check that. So regarding the functionality and everything, the parameters, everything are same. In fact, I could have added to my same application, but I just created this a separate one because I'm just learning with different modules, so I just created a separate application. So everything is same except the function that we are going to do. Last time we just prevented privilege escalation using eBPF and LSM, the same module, and today we are going to do some activity using the web application. And okay, before diving deeper into the theoretical part of this one, I will show you how can I do this. So in a normal scenario, all of you know this application well, so it's DBWA, and I just set up my security as low. This is a practice application, so everyone knows that, and it's very vulnerable. Nobody is going to put in production. So how this works is like here is a command injection possibility, and normal working is like it accepts a parameter, and the function is supposed to be, it should ping to the target IP. It doesn't matter whatever the user inputs. Actually it takes the input and it considers a target IP. And if you check the source code of this one, it's basically running a shell exa command behind the scene. And if you go through the PHP source code, you can find out how this shell exa works. I did go through the PHP source code, but it was pretty difficult for me to understand how it works, because they had a user defined their own functions, PHP functions that internally calls the system, Linux system calls, or what Windows system calls, that is behind the scene. Like basically it is cmd.exe kind of shell in Windows, and here it is bin as such in Linux. So that's what's happening. The main thing here is it takes whatever you given as the IP parameter as a target. So here is a catching point here on the low security code. It doesn't have any kind of filtering. It just accepts your input, whatever as you are entering here. So the injection is possible because, as I said, it is accepting the parameter without any filtering. And suppose these are the different ways of checking it. Like you can add ampersand, semicolon, or symbol, or pipe, or pipe symbol. Any of these will work. Like how it works is like whenever you are adding this command, just see what happens. It just takes it and it should, now it tries to ping to 1 because it considers the target of IP as 1, plus it executed this cat, it dumped this for me. So what happens is here, since this applications, the web app user has read permission to read the etc password, so it dumped it for me, and because it doesn't have any filtering on the parameter, it did execute both commands. So even you can try to create your own backdoor using this one. The command for that one is this. I got this one from, I mean, all these are available on the internet, so if you search for this one, you will get it. Basically it is doing the same thing. It tries to echo this line to and create this file, and see the dot will make it a hidden file. So it is just the same command shell exec is using and taking the input parameter and run the command for us. Behind the scene, yeah, it is going to run just like the command injection source code shell exec, but it is a different kind of it's a get command, I mean get method accepting input parameter. So how it works is, I will show this also, then we will move to our WAF stuff. Here I'm just pasting it, and this backdoor is just like it's not a reverse shell, it's just a backdoor that will help us to execute command on the server. So I'm just submitting this one. If everything goes well, this should work, and we can confirm it using checking here, and here on this one I think it is on exec. See, it tried to ping the to 1 as a target, because we have given 1 as a target IP, and then we created our file, backdoor file there. So what happens here is, I think, yeah, it's a hidden file, so I have to search for this one. Yeah, see, here it's created because this area, this is under the www html dbw folder, so this application has a write permission here in this folder. So it created that, and now if you want to see how it works, you just access that using the name on the same folder. Here you can see it is on here under the same folder under exec. Just give the name as it is, because it's a hidden file. You have to give the name exactly like that. I'm not showing an web app attack demo here. I wanted to show how these things work without my hook, and how these things going to work after my hook. So there is an the scenario is this, and the next thing is the parameter. It was a get request, so I'm just giving this query string, and any command actually you can see. Normally I have to change to cd etc to get this one, and this is a like it's logically we are just moving to etc folder and just trying to print the password. If that backdoor file was working, then definitely you will get it. See, you can dump this like this because the backdoor was working. So this is another scenario, and there's one more scenario on file upload that I will show. Okay, I will show you now itself. Okay, before that I have another Linux here. Just check my IP, and this one has 158. I think I have already changed that. My reverse shell PHP. I have a reversal, and this is not my source code. Actually, I got it from Pendas Monkey collection, and he has done a very good job. He is basically just sending the commands over the socket, writing, reading everything. You can see it here. The source code is very clear. If you check, you can see it's sending over the socket using the pipes. and yeah, it works well. Like I confirm my IP. It's 158. Yeah, it's going to be 8443. So from an attacker machine, I'm going to run this command, and I'm going to upload this file. And I know all of you know this because we are on a low permission, like low security in this one. So it shows, and it shows it is here. Copy, and I'm just pasting it here. So keep it here. Oh, it's a different machine. Okay, just run it, and let me see. We got the shell here, and we got a working bin as a shell. And normally you have the full, I mean, it's kind of shell but restricted user access. But again, you can run any command on this shell, like whatever you want. ls who am I, or even you can just see, because you have a read permission on these files, you can do the same thing here. So whatever the user has, whatever the user can do, like the restricted www data, I think that was who am I. So this user, whatever permission the user has, you can do the same thing in this reverse shell. So these are the things that what happened, why I'm showing these vulnerabilities, because these vulnerabilities has a different role than the web application, because it goes beyond the web application. It reaches the server itself. So the module that we are going to develop, or I developed and going to show you now, is a kind of firewall or web application. I don't know whether it's going to be a web application firewall, I can call it, or something else. But this context is clearly connected to this exclusive web app. So the scenario is like, suppose if the user doesn't, I mean, the application developers don't have the provision to change the code, they have to keep the code, but at the same time you have to secure your application. And that's a scenario that you can make use of this one. And why I came to web application, including to connect eBPF, is because recently I came across a demo of one of the famous vendors, and they terribly failed to block what I'm showing now. I can't reveal the vendor name, but yeah, that was a scenario. Then actually I planned for another plan to learn another module in eBPF, but again I tried to play with this web application area and find out what are the areas that the web application connects with the system or the server. So these are in this application, these are the areas that this application is connecting to the server. This what is that, file upload and command injection, and yeah, even the file upload time, the backdoors, how the backdoor is going to work. And yeah, there are two types of backdoors we uploaded now. One is the reverse shell, and the other one is a hidden file that does the same thing, like executing shell command. So all these things comes and into the system level. So here we are going to put our hook and block all these attacks. The source code, I will show you the source code. Source code is same as last time, and actually it is much less code, and that's the beauty of this one. That's why I like this eBPF. Sometimes once if you are familiar with this one, it's easier for you to convert your ideas into applications. So here, yeah, one more thing I have to say is, here for the demo purpose I just use user ID. How it works is like, so I defined the user ID here. My web app user ID is 33. So whenever it encounters 33, because I'm reading here, I have explained all these functions in my previous videos. So if you are not familiar, please try to go through that, then you will get a clarity on these things. But here what happens is basically I'm reading the current user ID and which file is getting executed, that comes in file name. The same like the method I use in preventing preventing privilege escalation in my previous video. Here we are ensuring that this hook is going to work only if the user ID is a web user ID. And actually one more thing I have to tell you, that this one is going to work on a user ID basis, but if there will be other scenarios where you may need to exclusively check the process ID, not the user ID, because you may have multiple applications, so you may need to put a hook on exclusive applications, not the entire users. Here I don't have any other application running on my server, so I'm just checking the user ID directly without going explicitly on process IDs of web applications. So here I have a map here, and in this map I'm using the same hash map type that I explained last time. My keys is the file name, and that value is actually doesn't matter here. I'm just putting a dummy value there just for the search purpose. And the key is, and the map is, last time we used not allowed bins to prevent privilege escalation, but this time I'm going to use allowed bins. That's going to be kind of whitelist that are allowed by this user to run on a web application context. So I'm just looking at the map, and map lookup is done by using the file name. The file name will have the actual binary or allowed binaries. So I'm checking whether that file name is there on my whitelist. If it is there, I just continue execution. If it is not there, I just block it. It won't execute. So just imagine a scenario, and you should know how this, definitely you will come to know how this hooks works once if you start programming this one. This hook is working for every command. Like whenever we are injecting suppose as an example, when I was saying the command injection with two commands, the first IP, then semicolon, the next injecting commands. So and behind the scene, even though you are getting the result, behind the scene what happens is this hook is getting called for every command. It calls for the sh command. The sh is needed for executing the ping and the other command that we are using, because they have the shell exec in PHP is using that kind of method to run the command. So it calls the first sh, then the ping, then the cat. So it will be like, it doesn't matter how many commands you are going to put there, all the commands will be coming here, and it will be one by one. First it will execute ping, then it will try to execute the cat or echo or whatever command that you put. So what happens after that is like whenever it comes here, this application hook will not allow anything apart from the whitelist that I have done. On my whitelist, it's basically the loader application. Here everything is same as the pseudo privilege escalation block. See, I'm loading, I'm setting up raise my memory, loading from the skeleton, and I'm getting the map file descriptor using the maps from my skeleton file. Then I come here, I create my whitelisted binaries, and this is important because in a normal way you may think you just need only ping, but yeah, it won't work like that, because the ping is called like bin sh, then ping, then your IP. That's the way it is working in shell exec of PHP. And normally, even if you want to do any reversals also, actually they utilize sh or any kind of shells, and then your command as parameters. So definitely we should, if you don't allow this one, nothing is going to work on from the user side, like everything will get blocked. You can try that if you want, you can just experiment with that. So I'm basically just looping over this my array and adding to my file allowed bins. So my allowed bins file descriptor I have from here, and I'm using that here to update my map and saying that this is the key, this file name is the key, and this is a value for that. This is a dummy value, doesn't have any role here. Then after that, yeah, that's it. It just loads and plays a hook. So now you saw how it was working without the hook, and now I will show you how it's going to work with the hook. So I'll try to show all the scenario. We'll try to print it here. I mean whatever the commands come here. So here I'm going to place my hook. So now the hook is in action. So let us go here, go to the command. I think okay, let me, okay, or keep it like this. I don't know, I didn't test this scenario. Just keep the shell like this. What happens? Let us examine what happens after that. So the attacker already had a reverse shell, and he got it and he was working on that, and we place our hook at that time. And the first scenario is this one. So we got the result back for this one. I didn't change the security is still low. So come to command injection, put this command, submit, and see if you can see how it comes here. See, it comes as such, then it tries a bin cat, then it tries a ping. See, it completely omitted the cat because I'm blocking the cat. So the block command was the cat, but the ping is allowed. So you can try different ways of doing that. It doesn't matter whatever ways. Behind the scene, at the system code level, I have a hook where I can filter it out. So it doesn't matter always it like this. And yeah, of course, the other one, this one also will fail because it tries an echo command here. And see, I wanted to show you different scenarios. Let me try this one. See, when where was that? sh bin cat. Oh, the echo command is not showing here, or did I miss something? I think it should be here. Okay, let me try with the same thing with a different IP though, so it will be clear. 127.0.0.1, and now we should get a actual ping result here, and the echo should be blocked. See, we got the ping result. So it doesn't matter whatever command we try apart from the ping, everything will get blocked, but the ping will be allowed. So okay, there's another scenario. We already have one file here. See, ls-a, still the backdoor is here, and before the hook I showed you how I was able to access the backdoor. So the same thing I'm going to do now here, cd/etc. So imagine this is another scenario, like after the hook anyway there is no way of adding this backdoor to the backend because we are completely blocking it. And imagine there is a scenario like it's already there and the attacker tries to access it again. So this scenario, just cat password. See, again it is getting blocked. So it doesn't matter whether it is already there and maybe the administrator didn't see that it is still there, but after our hook is placed, if the attacker is trying to get it, he will never get any result from this one because we are completely blocking that. The application is allowed only for ping, and only the ping will be get executed. So what happens on the reverse shell now? So I will show you two scenarios. Like now the hook in place and attacker is already having. I didn't test this scenario. Actually I was testing the other scenario after the hook and before the hook, the reverse shell, how it works. So before the hook, actually I got this shell, and now I'm trying to run. See, I'm directly getting so the attacker, suppose if he uploaded a file as a reverse shell and he was working on the shell, and after that sometime I place my hook, and if he is trying to do anything apart from this one, then he will get blocked. But he can, still the problem here, I mean it's not a problem, but still he can run ping command. So you should be careful on that one. And there is another way of blocking that. Definitely you can hook another LSM point where you can monitor the network activity, and you can completely filter out using the source IP whether it's going to be allowed or not. So it is another part, like I can implement it on next sometime after my part 4, but you can try that. Definitely there's a hook point and you can block it. So the main thing I wanted to show here is, even if the attacker had an access to your system, after the hook is placed, there is no use for the attacker with the shell. So I'm just exiting from here, and let us see what happens. So once if you just like the backdoor PHP, it was not working after the hook was placed. Means attacker was not able to allowed to upload the file using the echo command, because we are completely blocking the echo command or any command. So what the scenario is going to be like, I'm going to upload this file again, my reverse shell. See what happens. It should be the same scenario, like just like I showed you. Where was that? CD vulnerability, right? Not vulnerabilities. Yeah, the upload area was hackable, right? Just for the sake of CD hackable. I missed the CD uploads, I think. Yeah, you can see all the files here. I'm going to remove the file just for safety, because anyway we are going to upload it. Sudo remove reverse shell. Yeah, now let us try uploading. Okay, just home. Security is still low. Yeah, file upload. I didn't change anything on the file, so the IP and everything is as set it is. Still it is working because these actions doesn't come to the system level. It's all happening on the PHP Apache engine, so there's no role for the server here till now. So what happens after this is really interesting. Suppose after this, just like our previous stuff I showed, he will get a shell. Why? Because we allowed sh command, and the reverse shell basically is designed in a way that it is running sh shell behind the scene, and still we get the command. So what the attacker does after this, that's the main point. So once he gets a command and our hook is running, he will never allow to run any commands other than ping. The ping part, definitely you can block it using another hook. That's a different matter. But for this one, even if the attacker so our hook doesn't block file upload vulnerability, but it blocks a file upload, reverse shells or bind shells or whatever kind of backdoor that is going to touch the server. So that's it about the WAF using eBPF. Now you can decide on what to call this one, is a WAF or something else, but WAF was the first thing that came to my mind, just because, as I mentioned, I had a scenario where it was a famous vendor. We tested using the same application, like we placed the application behind their WAF, and we were trying to do different attack scenarios, and they failed to block most of the attack scenarios. And they were doing something else, because they didn't have this kind of control over the server, because the server they work it's like the request is going to them first, then it goes to the server. So it is for system level actions, actually eBPF is far better than normal WAF, because we do have more control over our system. So that's it about this video, and I will plan something for the next one next week. Anyway, I'm just scratching the surface of eBPF, and it's really an interesting tech stack that I have come across. Like it's an addictive one, so every week I'll try to come up with something. I'm just learning, and I'm just sharing my experience with you. So if you like the video, just stay tuned, and we'll see you on next video. Till then, it's a bye from Alphas.